What you are seeing here is not just Excel charts. It is a structured flow of energy-related information starting directly from the BIM model. On the right, we have the BIM model. All walls, windows, orientations, and room data are already embedded within the model geometry. From this model, we extract structured schedules, not manually typed data, but quantified and reliable information. This data is then organized into a master data table in Excel. Think of this as a clean database, read-only, untouched, and directly reflecting model quantities. Now, instead of manipulating the original data, we create logical views. These are analytical layers built on top of the master table. Each view answers a specific question. Which rooms have the highest external wall exposure? Which spaces have the highest window-to-wall ratio? And which rooms are most vulnerable to western solar exposure? So the key idea here is simple. Energy thinking begins with structured data. And structured data begins with the BIM model. Before jumping into HVAC calculations or energy simulations, we must first understand the envelope. Because envelope decisions silently define long-term energy performance. Energy thinking in BIM Episode 1, Envelope First Approach. Opening with ESZ internal heat load context. Before we even look at the building envelope, it is important to understand internal heat behavior. Here, we are looking at ESZ zones, which represent internal heat load distribution within the building. Different spaces generate different internal loads based on occupancy, equipment, lighting, and usage patterns. So energy thinking does not start outside the building alone. It starts with understanding what is happening inside. Once internal load zones are understood, the next layer of thinking moves to the facade. SHGC views solar control layer. In this view, we are observing SHGC, solar heat gain coefficient, across the glazing. SHGC essentially tells us how much solar radiation passes through the glass. Lower SHGC means better solar control. Higher SHGC means more solar energy entering the space. This is critical in warm climates, where uncontrolled solar gain directly increases cooling demand. So now we have two dimensions of understanding: internal heat behavior and facade-level solar control properties. But energy thinking becomes meaningful only when we connect this with envelope scale and exposure. Transition to Excel analysis. Let us now move to the structured analytical view derived directly from the BIM model. What we are seeing here is not manually created data. It is extracted from model-based schedules and organized into a master table. From this structured data, we generate logical analytical views. Chart 1 at directional external wall exposure. First, we look at directional external wall exposure by room. This tells us how much each room interacts with the external environment and in which direction. Larger exposed surfaces mean greater thermal exchange. But orientation matters equally. A room with significant western or southern exposure behaves very differently from one predominantly facing north. Chart 2 overall window-to-wall ratio. Next, we evaluate the overall window-to-wall ratio. This indicates glazing intensity relative to wall area. Higher WWR may improve daylight and aesthetics, but it also increases potential heat gain. So here we begin identifying spaces where glazing decisions may influence energy demand. Chart 3 a directional WWR western focus. Finally, we isolate directional glazing, particularly western exposure. Western sun, especially in the afternoon, can significantly increase cooling loads. Even moderate-sized rooms can become thermal stress zones if heavily glazed toward the west. This level of analysis allows us to identify potential energy-sensitive spaces, even before running detailed simulations. Closing concept. So in this episode, we have not performed energy simulation. Instead, we have structured envelope intelligence. We looked at internal heat zoning, solar control properties, external exposure, and glazing intensity. Because meaningful energy strategy begins with understanding the envelope, not with jumping directly to HVAC sizing. In the next episode, we will convert this directional exposure into a weighted solar index and move one step closer to quantifying thermal risk. This is energy thinking in BIM.
If you like the video, please like, subscribe the video and channel. This will encourage me more. Your comments will help in refining the content and defining the intent.